I don't think we're going to get all through. Just going to make sure that it's recording. It's recording. I don't think we're going to get all through optimal binary search. I don't know how. I was looking at the notes from last year. Last year I taught optimal binary search. I taught edit distance and this, and then I taught optimal binary search trees in the same lecture, and I did it on June 3rd. How did I get to this stuff in 1 month? That must have been a crazy summer. It's because I was making other people write scribe notes. I was not doing the lecture notes. That's how. So I was having an easy time, and the students must have been having it really rough. Okay, so can we, the max profit we can achieve from xi to x1 to xi with weight exactly j. So this actually doesn't actually make any sense, because we can't fill in, we can't get weight 1 with an empty subset. Right? So this is not defined. So we're going to say, what's the, with weight 0 and subset of size 0, we can get profit 0. This is not defined. Now, what we're going to want is, again, to compute aij, let's suppose we take xi. So if we take xi, then the max profit we can get okay, so this xi is the pair, right? So we take that. The max profit we can get with weight exactly j is a I minus 1 j minus w sub I, right? Because now I'm telling you, you take xi, so you plus pi. Right? So you take xi. So I'm telling you, you have to get weight exactly j, and that's going to include xi. So you have to consider, okay, what can you now get? You get the profit from xi, but now you have to think, what's the max profit you can get with exactly weight j minus the weight of the thing you just took, the weight of xi, wi. Well, you have this computed, right? Because it's sort of to the left. So if you take xi, then aij equals this. If we don't take xi, then the maximum profit, so this is defined as the maximum profit we can get taking taking some subset of x1 through xi minus 1, achieving this weight, and then when we take xi, we get weight exactly j, and we get this plus pi. So if we don't take xi, then the max profit we can get with weight exactly j is a I minus 1j, right? Because if you don't take xi and you have to get weight exactly j, then you better get weight exactly j from x1 through xi minus 1. Okay? So we have these two options, and we're going to take the max of these things. Right? So now I'm going to write. So we cannot achieve, incidentally, what is, with weight exactly 0, what is the maximum profit we can get with each of these? It's 0. Because assuming that the weights are positive, the only way you can get weight 0 is not taking anything, and then you get profit 0. Okay, so we're going to say, okay, A I0 equals 0, and A0j equals, well, not really defined, because you can't get weight 3 without taking anything, exactly 3. So equals question mark for j greater than 0. Okay, so now for I equals 1 to m, for j equals 1 to n, Aij equals max of this, a I minus 1 j minus wi plus pi. Can you read this, or is it too small? Is anybody there? 2 people have disappeared. ITD good, readable, yes, is good, okay. Or the other thing we can take is so this is, you say, well, this is if you take it and you can get more, and the other thing is you don't take it and you can get I minus 1 j. I just realized I'm sort of saying this stuff and I'm standing in front of the board, because this is why I like having these big classrooms with lots and lots of blackboard space where you can like write and then you can stand off to the side, and I'm not standing in front of what I just wrote. The only way I could not stand in front of what I just wrote is okay, so then N4 and N4. But now we can't just do this thing where we say print AMN, right? Because print AMN is going to tell you the maximum profit you can get exactly filling the knapsack. We don't want that. So we want to print max. I don't need an extra bracket here. I do if I were writing C. Max, I'm going to put a curly brace, because this is a set. Max over J of A MJ. Right? So this is saying, okay, now I consider the maximum profit I can get from any subset of the things, so x1 to xm, but I don't care how much they weigh exactly, I just want the profit to be maximum. So it's taking the maximum profit you can get over the top row, which will be the bottom row when in the lecture notes when I'm sticking to normal matrix coordinates. Okay, so let's fill in some of these. Okay, so what can we get? What's the maximum profit we can get with from x, taking x1, trying to get weight exactly 1? This is not defined because we subtract, right, this is I minus 1, so that's fine, but j minus wi is 2, so we're over here, we're off the matrix, this is not defined, okay? Or ai minus 1, j, this is not defined either, so this is not defined. Okay, here we're trying to get weight exactly 2, and from a subset of x1, just x1. Okay. So let's look at it. We say I minus 1 down here, j minus wi is w1 is 2, so we're here. So we're saying if we take x1, then the profit we can get from not taking anything is 0. It's actually defined, it's 0. So we wouldn't get weight not equal. So if we don't take it, so if I tell you, you have to get weight exactly j, and you decide not to take the item, then you had better get weight exactly j from some item or a subset of items that's that's up to xi minus 1. So here, if we're looking here, we're thinking, okay, this is I minus 1, you go down, and then you go to the left, wi, which is 2, so you're over here. So you're thinking, okay. And then you add pi, which in this case is 1. So here it is a 1, okay? The maximum profit you can get from x1 with, how is it 12:41? I have 13 minutes. Okay, it doesn't look like I'm doing optimal binary search trees today. How did we spend, the little camera is not record, 3, the little camera stopped? No, the little camera is still recording. I forgot to start the timer. Okay. But how did, it's 12:40, okay, so we have 13 minutes left. That's going to be enough to do knapsack, but it's not going to be enough to do optimal binary search trees. I can sketch them. Sine x, cosine x? What? Sine x? What? Okay, so let's do this. Let's just keep going. So 3, we're going to drop down and go over here. This is not defined. If we take it, if we don't take it, we just drop down 1. Right? So this is not defined either. So in fact, we can fill in the rest of this because there's no way to get any of these weights using selecting or not selecting just something with weight 2. Okay. So here we say to 1, well, we can, if we take it, then we're dropping down and going over here, but then we're off the side of the matrix, so that's not defined. And if we don't take it, we're just dropping down, and so it's not defined. If we take it, we're dropping down and going off the side of the matrix, so it's not defined, but if we just drop down, it's 1. So this is a 1, right, because we're taking the max. So what does this mean? It means the maximum profit we can get with a subset of 2, 1, and 3, 4. Remember, it's weight profit. The maximum profit we can get from a subset of 2, 1, and 3, 4 that has weight exactly 2 is 1, right? Because we can only take this one. Okay? 3, so if we go down and over 3, we get here. So it's defined, okay? So we have the option of taking x2, which has weight 3, and that would mean we would get profit 4, because it's 0 plus 4. Or we can not take it and drop down and try to get weight 3 from just x1. We can't do that, so this is a 4. Okay, here we can drop down and go over, and it's undefined, or we can just drop down, it's undefined, this is undefined. There's no way to get a subset of weight exactly 4 from these two. Then here, we can drop down and go 1, 2, 3, so this is a 1. So then we add the profit 4, so we could get 5, or we can just drop down and we get undefined, so the max is... So actually, I shouldn't have put question mark, I should have put negative infinity, so then the max actually makes sense. Okay, so this is a 1 plus a 4, so this is a 5. So think of the question marks as negative infinities. Then here it's 1, 2, 3. It's undefined. Just down is undefined. There's no way to get weight exactly 6 from weights 2 and 3. 7, 1, 2, 3, undefined. Down, undefined. 8, 1, 1, 2, 3, undefined. Down, undefined. Okay. Here, 3. So it's down, 1, 2, 3 off the side of the matrix, just down, it's undefined. Here it's down, 1, 2, 3, it's off the matrix, but down is 1, so it's 1. Here it's down, 1, 2, 3, it's 3 plus 3, 0 plus 3 is 3. Or we look down and we see a 4, the max is a 4, right? So what is the max profit we can get from the first 3 of these with weight exactly 3? It's taking this one. It's not taking this. Okay, then here we go down and we get 1, 2, 3, it's undefined. We just go down, it's undefined. Here we down, 1, 2, 3, it's 1, so it would be a 4, right? Because we're adding the profit 3, so it's either 4 or it's 5. The max is a 5. Right? Because what is the maximum profit we can get from these 3 things with weight exactly 5? Well, it's going to be choosing this one and this one, right? Not this one, because this is more profitable. So we get a 2 plus 3 is a weight exactly 5, and the profit is 1 plus 4, weight exactly 5. Okay, here we go down 1, 2, 3, so it's a 4 plus a 3, that's a 7. And down is undefined, so the max is a 7. Ooh, what does that mean? Well, how much profit can we get with weight exactly 6? We can take this one and this one, so it's weight exactly 6, profit is 7. This, so this one is going to be down 1, 2, 3, undefined, down is undefined. We can't get weight exactly 7 from these 3 things. And now down 1, 2, 3 is a 5, so 5 plus 3 is 8. We're down, so this is 8. Okay? So maximum profit we can get with, so yeah, I'm going to have time just to finish off this tiny example. And then I can't believe this was supposed to be half a lecture, not a whole lecture. We're behind. We must go faster, more material. That's sort of, I'm kidding. But I do have to squeeze in optimal binary search trees somehow. Maybe on the assignment. That's also sort of maybe a joke. I did it on the assignment last year. Okay, well, the first year I was here. The year that like lots of people didn't like me. Okay, here, 4, it's off the side of the matrix, down, it's undefined. You can't, still can't, okay. Down, it's off the side of the matrix, 1. Down, it's off the side of the matrix, so it's a 4. Down, 1, 2, 3, 4. It's a 0, plus profit 5. This is, so max of 5 and negative infinity is 5. This, 1, 2, 3, 4, undefined, down it's 5. This, it's down 1, 2, 3, 4, it's a 1, plus 5 is 6, but this is a max, it's a 7. This is down 1, 2, 3, 4, it's a 4, plus 5, it's a 9. Down it's undefined, right? And here it's down 1, 2, 3. 1, 2, 3, 4, it's undefined, and down it's an 8. So if we just reported the top, we have 5 minutes, if we just reported the top right corner, it would be like, yes, if we fill the knapsack exactly, the max profit we can get, we're down to 16 people. The max profit we can get is 8. And how would we do that? Well, the capacity is 8. We would probably, yeah, the only way we can get weight capacity exactly 8 is 2 plus 3 plus 3. But if we don't quite fill the knapsack, we leave, we can stuff in 1 more kilo, then the profit is 9 because we get, how do we do this? It's, so we take this one because 1, 2, 3, 4. We take this one, we take that one. Yeah, okay, we take this one and that one, okay? We take this one and go to the 4. We do not, if we took x3, it would have been 3, but the max came from here. And this is, this we get the 4 from here. So we take this one and this one, we get weight 7, but we get profit 9. So when we scan the top row, which takes linear time, we get the max. So when we print max over j of AMJ, we print 9. Which is, that was exhausting. Does everybody see how to do this now? My remaining 16 students, sort of. Don't worry, you'll get practice. I'm going to put it on assignment 5. You can always go back over the video. So the lecture notes should be better because I was accidentally like flipping. We should have been working downwards in order for I and J to make sense. How you derive the algorithm. Okay, so we have 2 minutes. So remember I said, when you're considering the subset x1 through xi. Your 2 options are, you take xi. Okay, in this case, if you take xi, so you're trying to fill in some cell of the matrix. And aij, now the magic is you have to choose aij correctly. Okay. So if you say it's the max profit, if you say it's the max profit we can get with weight up to j, then life gets hard. But so in this case, we're going to say, okay, it's the max profit we can get with weight exactly j. So you have to choose what aij is supposed to mean. You have to choose that right. That's the magic. I mean, people still publish dynamic programming algorithms, And the reason that we don't just feel like, oh, this is easy, anything you can do with dynamic programming, just plug it into this template. No, it's because you actually still have to think about, okay, exactly how many dimensions does my matrix have, and what is each cell going to store? So, in this case, you say, okay, Aij is going to be the maximum profit we can get from x1 to xi with weight exactly j. So now you're thinking, okay, so once we've decided that, you think, now if I take xi, then I'm going to think, so what is my budget of weight left? Well, it's j minus xi, right? Because if I decide, like my backpack, I've decided I want to fill my backpack with exactly 15 kilos. And I'm going to take this 5 kilo watermelon, which has profit 2. So I've decided I'm going to take that. So then I'm trying to figure out the maximum I can get in my remaining budget of 10 kilos plus the 2 I'm going to get from the watermelon, right? So that's how you say it. So if I'm looking at the watermelon and I say, okay, I'm going to imagine, suppose I take the watermelon, then I want to fill up exactly 10 kilos, and I want to get the maximum profit from that, from the stuff that comes before the watermelon. If I don't take the watermelon, then I have to fill up, I've decided I'm going to fill up exactly 15 kilos, but only from the stuff that comes before the watermelon. I'm not going to include the watermelon. And then I don't get the 2 from the watermelon, I just get the profit from that. So that's, in the first case, it's the 2 from the watermelon plus the maximum profit of ai minus 1, 10, the maximum profit I can get of the things before the watermelon with capacity, with weight exactly 10. And if I don't take the watermelon, then I just say, okay, then I have to try to get weight exactly 15. So I'm looking for the maximum profit I can get with weight exactly 15 from items that came before the watermelon. So once you've decided what your matrix cells are, then the rest is not so bad. Except, so now I'm over time, and I'm down to 14 students, except optimal binary search trees are actually quite tricky. But I've already planned what we're going to do for the rest of it. I'm going to have to pack the next lecture. But I'm getting vaccinated, it's supposed to be, on Sunday. So I might pre-record Monday's lecture. Okay, I'm going to stop recording now. I might pre-record Monday's lecture, and then I can go super fast and do optimal binary search trees and longest increasing subsequence in the same lecture. Not sure that's a hugely good idea, but I can try. Because I think, from what people have told me about what this vaccine does to you, maybe I'm not going to want to try to do that on Monday in a live lecture. Also, that's the problem. Like, I sprained my elbow last week, so my arm is already sore. It'll give you magnetic powers. Oh, that's cool. But I think the little camera is metal, so that would be even harder to set up. Okay. Thank you for hanging around 3 minutes overtime. I hope you understand at least subset sum and knapsack, and now you're starting to get the feel for how dynamic programming works. Good luck with assignment 4. Assignment 5 will be coming out soon, but assignment 5 is not going to be due. Oh no, assignment 5 is not going to. So because assignment 5 will maybe not be coming out on Friday. Yes, it will, but it will involve stuff that you don't know yet because I want to pack in Monday's lecture onto assignment 5 as well. Because then we can do like one assignment for dynamic programming and then move on to NP completeness. Okay. Any more questions? Any concerns? Anything? No. Ciao. Have a good weekend. Put it, take time within